All right, so let's do a couple problems from the first part of the problem set from lesson 8 in module 3. So this is one of the harder problem sets I will assign all year. This lesson is the first lesson in which we have to actually start writing equations with variables in them to match, whatever word problem they've given us, and then we got to solve that equation. So to solve those equations, we're going to use what the book calls if-then moves, but we're referring to them as the properties of equality. But generally speaking, that's the easier part of this process, solving the equation. The hard part is setting that equation up and all the stuff you got to do with setting up the equation, like defining your variable and expressing all the quantities in the given situation in terms of that one variable, because we only know how to solve one variable equations right now. You'll learn how to solve equations with more variables in them next year and beyond. So let's look at, how about we just do the first one? It says the perimeter of a rectangle is 30 inches. If its length is 3 times its width, find the dimensions. So my advice to you always is to start off by defining your variable, and your variable should always be the thing that you need to know you need to figure out, but the question has told you the absolute least about. The two quantities we really need in this question for number 1 is the length of the rectangle and the width. They told us a little bit about the length. They said that it's 3 times more than the width. They didn't really tell us anything about the width. That means that's the thing we should make our variable. So I'm going to define the variable w as the width of this rectangle. Then we have to consider this other quantity that's in the problem, the length of the rectangle. And we want to write something about that length of the rectangle, or we want to express that length of the rectangle in terms of the variable we already have. We have to write it in a way that uses w and no other variable. So I'm going to write that 3w equals the length of the rectangle. And I'll shorten rectangle this time to just rec. And that's because the problem told me that the length is 3 times its width. So 3w. Now, we don't really need to draw this whole diagram over here. Well, let's just think about it for a second. In a given rectangle, you've got, we can call this side the width, and we've got this side the width. And so this side would be what people call the length, and this would be the length. But in both cases, I can represent the length as 3 times the width, 3w. So really, this wasn't a very good drawing. If the length is 3 times the width, this should be like a skinnier, longer appearing rectangle. But whatever. All right, so now to find the perimeter of a rectangle, you just add up the sides, the lengths of the sides, I should say. Don't do width times length. You're thinking of area if you do that. Perimeter is just the lengths of the sides. So the equation we can write from this is just adding these 4 sides up. W plus w for the 2 widths plus 3w plus 3w for the 2 lengths. And then that's all supposed to equal 30 inches according to the question. I'm just going to write 30. We can put our units on our final answer. I don't need to put an IN in the middle of my equation, because you do that and then it's possible where you could look at IN for inches and forget and maybe think that N is a variable in your equation or whatever. So I'm more of the philosophy that let's just put our units on the final answer. So w plus 3w plus 3w, that is 8w. And that's supposed to equal 30. And now we're going to use the properties of equality to solve this. I see that w is being multiplied by 8, so we have to undo that. We're going to do the inverse operation, which would be to divide by 8. And anything we do to one side of the equation, we must do to the other side of the equation to keep things equal. And so that means that w equals 30 divided by 8. Well, I know that 3 times 8 is 24, and I would have a remainder of 6. So that's 3 6/8. But 6/8 simplifies to 3/4. So I'll write it as 3 3/4. You could have written it as 3.75. You could have written it as 30/8 and then just simplified that to 15/4. In fact, that might even have been the better way, but whatever. So W equals 3 3/4. The question says we have to find the dimensions. That means the width and the length. We only have the width right now, so I need to find the length. So the length equals 3W, which equals 3 times 3 3/4. I think actually to make this multiplication easier for myself, I am going to change this 3 3/4 to 15/4. So 3 over 1 times 15/4 equals 45/4. And if you wanted to, you could simplify this back down to whatever that would equal, 11 1/4 or whatever, but I'm okay with just leaving it as 45/4. So let's put units on our final answers. The width will equal 3 3/4 inches. And the length will equal 45/4 inches. All right. What other ones should I do? I think I'll do number 5 for you. So let's look at number 5. It says, Justin has $7.50 more than Eva, and Emma has $12 less than Justin. Together, they have a total of $63. So that tells me I'm probably going to add up how much money each of them has, and then it's going to equal 63. How much money does each person have? So we have 3 people, Justin, Eva, and Emma. They told me a little bit about Justin because he has $7.50 more than Eva. And they told me a little bit about Emma because she has $12 more than Justin. The person they did not really tell me anything about is Eva. And that means I'm going to use her amount of money as my variable. So I'm in the question 5 box now. I'm going to probably need a lot of space for this one, so I'm going to write kind of small up over here. I'm going to say that the variable, I'm not big on using E as a variable. E is actually its own special number, kind of like pi. What variable do I feel like using? Well, her name ends in an A, so I'm going to use A. A will equal Eva's money. And now we can write how much money Justin has and how much money Emma has in terms of Eva's money. So let's go back to the word problem here. It says that Justin has $7.50 more than Eva. So that one's relatively easy. We'll say that A plus $7.50 equals Justin's money. Emma is a little bit more difficult. It says Emma has $12 less than Justin. So we have to go back and look at what we wrote for Justin and then subtract $12 from that because he has $12 less. So A plus $7.50, which is Justin's money, minus 12, because Emma has $12 less, will equal Emma's money. And so now we have all 3 people's amount of money written in terms of this variable A. All right, we didn't use a J for Justin's money or another variable for Emma's money. We used A in each one. That's going to allow us to combine all the like terms and solve this equation. This part right here can be simplified, and I'll do that when I build the equation. So the word problem says together they have $63. So that means I'm just going to add this, plus this, and it's got to equal 63. So I'll start up over here. A plus $7.50 plus A plus $7.50 minus 12 equals 63. Okay, so I added this, plus this, plus this. Here's Eva, here's Justin, and all these things here at the end are Emma's money. Okay, so now let's combine the like terms. I have 1, 2, 3 A's. So 3A plus, well, 750 plus 750 makes 15, but then minus 12, that's 3. So 3A plus 3 equals 63. And now we have what's called a two-step equation, because we're gonna have to use the properties of equality twice to be able to solve this. I see multiplication happening to our variable a, and I see addition happening afterwards. In order of PEMDAS, it would be multiplication first, addition second, if we were to evaluate the left side. When we're solving equations, we always do the inverse operations that we see, and we do them in reverse order of PEMDAS. So if I were evaluating, I do multiplication, then addition. In order to solve, I'm going to handle the addition first, then the multiplication. And I handle them by doing the inverse of what I see. I see plus 3. I'm going to subtract 3 from both sides. Positive 3 and negative 3 make 0, or in other words, what people like to say, cancel out. And so on this side, we're left with just 3a equals 63 minus 3 is 60. Now I see that 3 is being multiplied by a. I want to do the inverse operation of that by dividing both sides of the equation by 3. And so when you multiply a number by 3 and then you divide it by 3, those two things cancel out, as people say. Really, they just multiply to 1, so we're left with 1a. A equals 60 divided by 3 is 20. And we're dealing with money, so I should put a dollar sign. And technically dollar signs go in front of the dollar, not behind, but whatever. All right, so Eva's money is $20. Now we can figure out how much Justin has and how much Emma has by just taking our $20, substituting it into the expression that we made for each person, and figuring out. So for example, Justin, well, that's A plus 750, which equals 2750. And then Emma, that's just $12 less than what Justin had, right? It's the same expression for Justin, just minus 12. So Emma has 2750 minus 12, which equals 1550. And you could verify if you were right by adding all these up and making sure they add up to 63. Just looking at them, I can tell that they do, so I'm pretty sure we're right. All right, so as you're doing these, please make sure your work looks like this. Make sure that you're defining your variables, you're writing all the quantities in the given problem in terms of that one variable. You're setting up an equation. You're showing that you're using the properties of equality to solve step by step. Everything's nicely labeled. Your final answers have the units on them. It was inches in the previous problem. This one's dollar signs. All these details, please make it look nice. All right.